Very good morning to you all. People still have the weekend mood.
Good morning, teacher.
We had introduced vertical motion under gravity. We did some calculations on that. Now we have to go for proofs. Someone has run away. But as we wait for people, let's review an example in calculations. If I can introduce what? Proofs today. So there's an example here. Let's take a look at this example. This one right here. A body is projected vertically upwards with a velocity of 21 meters per second. How long will it take to reach a point 280 meters below the point of projection? So the particle is projected. I'll take a screenshot. From here, it goes up and comes back down. So they're asking us how long will it take to come and fall 250 meters below the point of projection. Remember, if we recall, we said when a body goes below the point of projection, the height it covers is negative. So if this is the h, it will be a negative h. So from s is equal to ut minus gt squared over 2. The negative h is equal to ut minus gt squared over 2. So give me a negative 250 is equal to the initial speed. Initial speed was 21, which is 21t minus 9.8 t squared divided by 2. When you divide the 9.8, you get 4.9. Therefore, 4.9 t squared minus 21 t minus 250 is equal to 0. And we can solve this with a calc. But you remember to write down the formula you're using. If it's bulldozer, you show us 21 plus or minus square root of 21 squared minus 4 times 250 times 4.9. Because the 250 is negative, to bring about a positivity. All is over 2 times 4.9. So press the calculator after writing this statement get me T1, get me T2. Someone press the calc. What answer did we get? Guys, do we all know how to press the calc? Get the answers? Do we all know how to get?
9.6, x1 is equal to 9.6.
Okay. And next two.
Negative 5.3145.
Of course, we say time cannot be second, negative, because this is real time. So the answer is actually 9.6 seconds. Okay, that is a review whenever a particle is projected below the point of, and comes back and goes below point of what? Projection. Now, I sent you Humphrey, and you'll have a look at some of these examples of 2.2. Humphrey doesn't have exercises, he calls them examples. But of course, his examples are very interesting, so you better take a look at them. Let me wait for one more person. As one more person comes, let's look at number 4. A body is projected vertically upwards from the top of a tower. Vertically upward means going vertically straight up, then comes back down. Then it says, with a speed of 40, and takes 3 seconds to reach the ground. What is the height of the tower? So we do not know the height of the tower. But all we know, from S is equal to UT minus GT squared over 2. The height is going to be negative because it is going below the top of the tower, is equal to the initial speed times time minus GT squared over 2. With this, you can see that a negative h is equal to 40. The time is 3 seconds minus 4.9 times 3 squared. So a negative h is going to be equal to 120 minus 4.9 times 9. What do we realize?
75.9.
H is equal to 75.9 meters. This book has answers in the back, so you can always check them out. Did I send you the book? I asked you that. I think I did. You have Humphrey, not? Let me resend it so that people can always cross-check with the answers and confirm. I've resent the book. Let me also look at number 6. How many people do we have? Yeah, we are still at 4. Or people have problems. They come in, they go off. They come in, they go off. Now look at number 4. Is it number 4, number 6? Number 6 says, a body falls from rest from the top of a tower. It falls from here, from the top of a tower, and during the last second, it falls. You can see what is that value, 9/25 of the whole distance. During the last second, the time it takes to reach down here is t, then this is t minus 1. Remember distance in the nth second, we are now applying those conditions. So the distance it is falling between this last second is 9/25 of h, assuming h is the entire height of the what? The entire height of the tower. Find the height of the tower. The initial velocity up here is 0. The balance here would be h minus 9/25 h, which is actually 16h out of 25. Let's call this h1, and this h2. So to start with, because the body is going down, from s is equal to ut minus gt squared over 2, shall have h1 a negative is equal to the initial velocity 0 minus gt squared over 2. You know what that means? It means that if I have h1 is equal to gt squared, when I divide by the negative, these become positives. So it means that if a body is just dropped from the top of a tower, one can neglect the negatives. But if you are not sure, go by the definition that whenever a body is dropped or goes below the point of projection, height is negative. When you analyze it, it will still reduce into a positivity. So this one, height h1, has a time t minus 1 actually, I'd forgotten, squared. And this height is 16h over 25. Then the second height is the whole of the h. The whole of the h, we are taking the time t as it is. Therefore, one can make t the subject as t squared is equal to 2h over g. So when you realize this, you can be in position to substitute and simplify. So these numbers we are going for, the reason why I first looked at some of these numbers, they require some critical thinking, and they require you to have all the definitions of vertical motion. Now, because we have already seen h1 is 16, you can actually even do this. You can first substitute for h and say, if I've seen that this is h with equation star, this can be Roman 1, I can say, if I put star into Roman 1, I'll have 16h over 25 is equal to g out of 2 into t minus 1 squared. But remember, we have already seen that h is something, so 16 over 25 times h, which is gt squared over 2, is going to be equal to g over 2 into t minus 1 squared. This can lose the g, it can lose the half, realizing 16t squared out of 25 is equal to expand t squared minus 2t plus 1. On simplifying, you get 16t squared is equal to 25t squared minus 50t plus 25. Algebra calls for 9t squared minus 50t plus 25 is 0. Press our calculator. Well, of course, writing down that you're using the quadratic formula. This is 900 minus 2,500, you get 1,600. Under the root is 40 over 2 times 9. So this will give me 50 plus or minus 40 out of 18, which will give me 90 out of 18 as T1, which is 5. Then T2 will give me 10 out of 18, which is what? 5 out of 9 seconds. Of course, there are 2 times. Now there is this time which is short, and then there is this time which is big. So the bigger time is the longer time. So when you use the longer time, you will find that 5 squared is going to be equal to 2h over g. H will be 25 times 9.8 divided by 2. By 2 once, by 2, 4.9. 4.9 times 5. That is approximately what? 125? 124.5. 4.9 times 2 is 9.8, which is 98. 98 plus 20, 4.5, 124.5, 100 something. Someone will give me the answer.
$122.5.
122.5 meters. Okay, that was how question 6 had to be handled. You can take a screenshot for it. Then you'll download it in your notes. With the students' effort. Okay, so with those definitions, there is a number for a stone which passes a window. Number 9. Please, this is a very good exercise. I'm going to do the proofs which are there. The rest of the numbers, you'll handle them. But let me also do this number 9. It's a very interesting number. And others get a challenge of interpreting it. A stone falls past a window. The window is here. The window is 2.45 meters high. The window from the ground, it is 2.45 meters what? High. in 0.5 seconds. So it is bypassing the window in 0.5 seconds. Find the height from which the stone fell. Fell. You don't have a problem with those two words, fall and fail. Which one is which? Which one is used when and why? So if you end up hearing me saying fall where fail should go, fall where fail should go, don't penalize me and say, teachers English. Those two words I accepted. They confuse me very well. Now, according to this number, they have said a stone falls past a window 2.45 meters high in 0.5 seconds. Find the height from which the stone fell. It's coming down. We are asking ourselves, what height did the stone come from? But as we ask ourselves that, when the stone clears the window, it has traveled a distance, which is h minus 2.5. And the time it takes to clear that distance is 0.5 seconds. And it just falls, so it came from rest. So, as it came from rest, from S is equal to UT minus GT squared over 2, a negative of the height is equal to 0 minus GT squared over 2, which brings about a positivity. So with that, H minus 2.45, the height we have traveled, in what time? In 0.5 seconds, is equal to 9.8 times 0.5 squared divided by 2. When you cross multiply, we shall realize 2h minus 4.9 is equal to 4.9 times a quarter. So 2h will give me 4.9 plus 4.9 times a quarter. Actually, this is 4.9 into brackets 1 plus a quarter. And this will realize 2h is equal to 4.9 plus 5 times 5 over 4. With this, finally, h is equal to 4.9 times 5, that is 24.5 divided by 8. Our h is going to be 3 point what?
$3.0625
meters. Okay, so that was number 9. So I think we have activated our heads rightly. Other people might not attend the lesson as per what we have. It's 9:30, they are not yet here. Let's proceed. So I'm going to introduce proofs. This was number 6. Take a screenshot all the time. And the first proof I've seen is right here. Number 10. Number 10 says a particle is projected vertically upwards with a velocity of u meters per second. And after t seconds, another particle is projected upwards from the same point and with the same initial velocity. Prove that the particles will meet after a lapse of that time from the instant of projection of the first particle. Okay, if you have taken a screenshot, I want to rub off this illustration. That is number 16. It's a proof. Therefore, we are saying the particle is projected vertically upwards with the speed u. We are projecting the particle with the speed u, velocity u. After t seconds, this particle goes. After t seconds, we project another particle. Now, if this one takes a time, this is particle 2, this is particle 1. Particle 2 takes a time of, if this one takes a time of capital T, this one which is projected later takes less time. By what difference? By a difference of small t. If you have assumed the second one has capital T, the second one will have, the other one will have capital T plus small t. Because the first one takes more time on the way before they collide. So if they have collided here, they have collided there. The question is saying, and after 80 seconds, another particle is projected upwards from the same point with the same initial velocity. Prove that the particles will meet after a lapse of that time. When they meet, this is the condition. When they meet, they are at the same height. So from S is equal to ut minus gt squared over 2. The first particle has distance